put data into a space-filling curve, you got to tell me how, Jay, you got to tell me how much time. Like, give me a flash of like 3 minutes, because I can do this for hours.
I'll give you a 5-minute. I'll give you a 5-minute mark.
Yeah. So, we've got this algorithm. When I started using the algorithm, which is a space-filling curve, there's several mathematicians that identified these back in the 1800s. Peano was one of the first. Hilbert is another. Hilbert did all kinds of shit. And one of them is this space-filling curve that I use. It turns out that our DNA is organized in 3 dimensions with this curve, right? So we can take data and we can put it into a space-filling curve. And what I do is I take programs and put them into a space-filling curve, and it creates patterns. And when you turn a program into a picture, you can do all kinds of stuff with that. You can ask, is this program similar to another program? So I don't want to run bad programs. I want to run good programs. And I want you to run good programs. And so how do we tell the difference without running code, whether or not it should be run? So I call this the starting problem. This is different than Turing's halting problem. Rather than trying to understand when a program should stop, we try and understand when a program should be allowed to run. Because I think this is a big problem on the internet today. And so, am I over? Is that it?
No, keep going. Got 6 more minutes.
Is that countdown?
Yeah.
Oh, awesome.
Countdown.
So, we can take data and we can put it into this space-filling curve. Now, it's difficult to do on CPUs because life, right? We're multicellular. There's 3 trillion cells in our body, and we are all working to give you this talk, right? That's fucking crazy. In each one of the cells is about 6 meters of DNA that is not tangled. Now, I used to work at the university in agriculture, right? I took care of the plants, and I had to coil hoses, and the hoses are like hundreds of feet long. And so I don't know if you ever got your hoses tangled up and had to coil them, but it's fucked up. It's hard to keep that shit, and we're talking about 2 meters of molecules we have to arrange. Okay, so what is fascinating about this is that all life uses it. You can't change it. You can't change the algorithm that runs you. And it's super important. Where the fuck did it come from? 4.7 billion years ago. How did that get here? Right? There's an information exchange going on in space, sending code to different places.
The format is also supposed to involve a Q&A if you want to stop
Oh,
doing that.
okay, so I'll give you my bad idea, and then you can ask me questions about it, because so many people here like identity. And I know a couple of you have heard this before. So we take our DNA, we take the X chromosome, because females have 2, males have 1 X chromosome. We take that X chromosome and turn it into a 96-bit identifier using Hilbert curves. If it was like audience participation, I would have gotten you all to say that. So we can convert your DNA into a 96-bit identifier, put that into IPv6 address, and now we've solved the identity problem for the internet. Who wants that? Who wants that society? Who wants that world? Not me. So let's make that illegal. That's my idea. We should not have an internet that is based on our biological data. Every packet should be anonymous, not identifiable. So, questions? Woo!
Any 2 packets from the same place won't be anonymous anymore.
Right. There is a twins problem, but we can do that over beers. All women have 2 IDs. No, the X chromosome in women is the same. I believe so, yeah. And besides, if they're not, I can still solve that problem. It's an edge case.
There's 2 different chromosomes for like you actually do the skin.
So the X chromosome doesn't do any outwardly identifiable traits. We could choose a different chromosome and it would put all the white people in one part of the internet address space and all the Asian people in another part of the internet address space. And I think that we have already decided that that's a bad idea. True? Hey, thanks. Appreciate your time.
We will see if we can get this to work. This is a, right, so I need the adapter. You have the adapter?
Is there one?
Someone took did the first guy take the adapter?
Here, I thought there was one right here. This should be one. Is that one? You need USB-C.
But this is a.
This is not.
What is it you're trying to go from and to?
USB-C to HDMI.
Well, I have an HDMI.
Have analgesic properties, and it's helpful for relief of muscle pain. And yes, the molecule sort of looks like a blockchain, right? Snake oil somehow has acquired a bad name, a negative connotation, as we experimentally determined in this room. A few things to know about snake oil. One, it's really expensive because it's from Chinese water snakes, has to be imported. It's exotic, it comes from Asia. And it's really hard to tell from cheaper oil. So what happened in sort of the gold rush days is it got to be popular with the Chinese workers came into California, and miners worked hard, got muscle aches, and they discovered this Chinese medicine, which is to put snake oil, to rub it on the muscles, and it relieves pain. So at first it was good, but then marketing hype took hold of it. It became a cure-all with magical properties. This guy, Clark Stanley, was the snake oil king. He
Yes, indeed, it does have analgesic
sold it
properties.
for almost everything. And you got to read this.
Muscle pain.
This
and yes, the molecule sort of looks like a
advertisement.
blockchain, right?
Snake oil
That's
is
what blockchains
snake
look
oil
like,
liniment is good for man and beast.
However,
It gives immediate
Blockchain.
relief. It's good for everything a liniment ought to be good for. But this got carried away and started being marketed for everything. It's magic. In 1917, a snake oil liniment was found to contain absolutely zero snake oil. Today, when we hear the word snake oil, we think of something as a fraudulently hyped solution. that doesn't do what it's claimed and might not even have any snake oil. Also, it's Chinese, and so there was all this racist feeling about Chinese medicine. Snakes, come on. All right, so obviously this talk is a metaphor about blockchain because there's good stuff in it, right? But it's being sold as something miraculous, widely marketed as a solve-all. It's fabulously expensive, and we can argue here that it's almost never needed if it's, the really narrowly defined blockchain. So I can stop for questions right now, or I can keep on going, but that's the core of my message about snake oil.
Why accept it?
Right.
You can go if you want to.
So my message when I give it is basically that there's a lot of interesting things that's going on in the blockchain world. It's been going on for 20 years, and solutions can do magical things, but they're not necessarily configured like the orchestration of technologies that blockchain is. So I think people here understand that, and we have to get that message out to everybody else. And so the term I have been promoting is not chain. It's not really blockchain, but it has all the same stuff. It's not chain. So I can take questions.
Why did the librarian say 80% unfavorable?
So the question is, why did the librarians think it's 80% unfavorable? Mostly because a lot of people, in the library world are saying silly things about blockchain in terms of proposing it as a solution for storing metadata, for making things immutable, and those technologies are, there are appropriate technologies to do all that, and everything will work just fine if you take out like the blockchain part of blockchain, and that the technologists have to battle their staff that said, oh, why don't you use this IBM blockchain thingy to do our patron database? But it's totally ridiculous. Back. Do I think there's something different with the hype cycle of blockchain? I think the applications for blockchain are much narrower than sort of the financial industry or the VC industry seems to think. And I think they've had and there is certainly a lot of real scams that are just that there's no blockchain in it, and they're trying to just take people's money. And so I think in many of the previous hype cycles, that's not been as true. You want to take more questions, or?
Yeah, you're out of time.
Do you want to? Okay, great. Thanks, everyone.
Okay, while Paul's getting set up, there's a bio on here, so I'll do a brief intro. Paul is the co-creator of the Beaker browser and an active contributor to the DAP protocol. And previously, he helped found the Secure Scuttlebutt project. He has a history of working at small web development agencies.
Hey, everybody.
Hi.
How's everybody doing? Good. Okay, so the name of my talk is a web crawler in your browser. I set this up to be very lightning, so we're just going to rock and roll. Okay, so I'm going to talk about my favorite database, the web. The web is, in a sense, a giant store of files, right? Each of these have addresses, HTTPS or DAT, any of these hypermedia protocols that address these files that you can access across the giant database that is the web. You can have pictures in them, video, web pages, of course, and data. And my favorite kind of data is JSON, because it's really the best form of data, the one that's kind of native to the web that we all use all the time, parses really quickly, all that good stuff. So, in the DAT protocol, which we're integrating into the web browser, the DAT website is kind of like your personal database. You're writing files from your applications into this thing as a way of both messaging people, publishing information, or storing information just for yourself for later use, your to-do list or your grocery list or whatever. And so whenever you want to publish something like a tweet, you write a JSON file. It's a post file. You put it in your post folder. It's a nice little JSON. You want to make a comment on somebody else's post. It's another JSON file that you just write to your personal web store that's your personal website. You want to upload something, another JSON file, right? So our database is full of JSON files that anybody can access across the globe. Lots and lots of JSON. Really simple way to do things. It's the way that I like it. And the JSON is really simply straightforward. We have a little bit of metadata identifying, okay, what type of information is it? It's kind of like a really scaled down approach to what RDF accomplishes, where we just want to be able to at least know what the schema is supposed to be and identify that schema and validate it correctly. A little bit of metadata like timestamps and stuff, but the content's really straightforward. This is kind of a tweet. Hello world, there it is. Now the question is, how do we take that kind of a model and turn it into an entire replacement for Twitter or Facebook, the kind of social applications we use all the time? Not just posts, but we want to have comments and little emoji reactions to things and upvotes and all the kind of stuff that you expect out of a social application. Well, the answer is we stick a crawler in the browser. And this crawler is going to go out to all the DAT sites that's in your little social network, find those JSON files and pull them into a database that you can run queries against. So whenever I have my little social application, my little Twitter clone, and it wants to say, hey, I want to make a feed, so give me all the recent posts for all the people that my user follows, you'll just talk to that database that's been crawled by your browser, and it'll pull out all those JSON files that it's found on all the websites of people you follow. And that's how you can assemble a nice social feed. And so we basically baked in this notion of being able to follow a website into the browser. You land at one of these DAT sites, and you can just say, all right, open up a little identity cert and say, oh, I'm going to follow this guy. Go ahead, crawler, call this guy frequently, pull down the most recent JSON post, stick it in my little database so that I can run applications against it. And so it'll crawl all the sites that you follow directly, and then to some degree it's a crawler, so it doesn't have to just do the ones that you explicitly follow. It can also look at who they follow and do a friend of a friend expansion and kind of branch the network out so that you're seeing more content. And that's how you get a nice and interesting database that is lends itself to discovery. So you might not necessarily show the posts of people that you didn't explicitly follow, but maybe the comments from people that are friends of friends, so that you can have a more kind of vibrant group conversation, or websites that they've published, or bookmarks that they've published. These are all things that we're integrating into this network so that you can discover content, and you have a little bit of a kind of a social connection to these people that are friends of friends, so there's some kind of responsibility to it. It's not just totally random people. And so this is the design that we have basically approached with this protocol called Unwalled Garden. It's just a souped up RSS almost. It's a way of publishing files, and you use the API to follow somebody, and then you use the API to write post files and sync all that down into your database, and the web is your crawler. So there it is, lightning talk done. So time for questions? Yeah, let's do it. Sorry, I think your hand went up first.
So you touched on RSS at the end. What exactly does it do about let's say RSS? Would you maybe expand on that?
Yeah. Conceptually, RSS is very much aligned. It's the underlying model is exactly the same. RSS, sort of the design, as I understand it, you're putting together a single file that represents all the activity, and to my thinking, it was just kind of like, well, we could go with that, but it's a little bit of a dated technology. It uses XML, which is not as popular now. And with the dApp protocol, we're actually able to very easily find out recent writes to an archive because every dApp website maintains a log, kind of like Git does. So we can really quickly find out, a site that I'm following, oh, okay, there have been 5 updates since the last time I crawled this thing, and 2 of them are posts that I'm interested in. So we don't need to have one file that maintains this kind of centralized index. We can do a quick scan of the entire folder structure to find the JSON files we're interested in. And so by having our own standard that we do off JSON, we're able to come up with all the different schemas that we want to be able to support. Any kind of data that you can aggregate together, a piece of information you can certainly operate with. So if the crawler is pre-programmed into Beaker right now, as the tooling gets better for running custom crawlers, I think that's something that we could definitely look into, or you could just run a service somewhere that taps into that network. DC.
Yeah. If someone wants to try a walled garden and see it and play with it, what is the easiest way for them to do that?
Wait about 2 months. It's so close. We're almost there. We're in the process of wrapping up a protocol improvement to dApp that really boosts scaling. So we want to get that done so that people don't have to go through the pain of migrating to the new technology. That's not yet sure it's going to be backwards compatible, so probably something. But also just the browser is almost there.
But if people install Beaker now, it will auto-update once it's ready.
Cool. So, Beaker, yeah, the Beaker browser, beakerbrowser.com. Yeah, if you search for it. Yeah.
Is there a way, so you said that we can follow people who post their who post messages and things. Is there a way for people who are strict who can follow them or who can see the messages that they post?
So if you're publishing in plain text, no, right? It's going to be there for anybody to read, just like if you have a website now that is on a static server. The solution to that will be, we'll probably come up with a couple of different tools you can use. One of the simplest things is at-rest encryption, which once the identity layer is suitable for distributed keys, if you just publish your public keys as a file on your dApp site, then other people will be able to encrypt for you using those keys. So we'll probably do that, and then also having things like messaging channels for things where you don't want to have the at-rest file being published on the network. You have higher secrecy. That's probably how we'll approach it. Yeah.
So just following up on that, you're saying the identity approach is a public key?
So each of these dApp sites have a public key as their address. So instead of an IP address, it's a pub key as their sort of domain things. Now you can use DNS as well that maps a short name to one of these pub keys. Sort of up to you. But then people will build a sort of social graph around your website address, and that's how they will start to have signals that say, this is Paul Frazee, the Blue Link Labs website will point to me, and it's directly where that's Paul. So this kind of identity confirmations will be.
Do you have any concern about the scalability, the usability of the keys?
In terms of people having to maintain their private key and the problem of key loss and stuff like that? Of course. It's, you got to make sure that you give people good recovery options. If they lose their key pair entirely, you need to have good ways to rotate them. So the answer is yes, and we're taking it seriously, but I don't have any great answers for you. Anybody else? Oh, yeah.
Did you review or find useful or anti-useful any of the work that came out of the W3C social web working group regarding activity streams, activity pub, these social data vocabularies that you could use in that JSON? Is there any reason that wouldn't be compatible?
So first of all, I love the work that Activity Streams is doing. All that is great. One of the kind of blockers to adopting it is that the model, the networking model is mailbox based, which is built on the presumption of a federated system of active servers that can send these messages between each other. That didn't quite jive with the model we have here, which is more RSS-like. So with that, it began to be like, okay, so maybe I could take some of the vocabulary and work from that. But ultimately, I just kind of felt like we wouldn't have a great interop story right from the get-go because of the different computational model, the networking model. So I was like, all right, well, why bother? I'm just going to do it. So, yeah.
Tim. Switch out the slides.
So when you say when we check to see that sleeping is one of which we impact, see that the design even that's the CCP as well as so we want difficult to sort of get
So-
if one question.
Could you repeat the end of that question?
So you have a protocol which involves a whole bunch of JSON files pointing to each other in the web, and your example uses that.
Yeah.
It could use HTTP presumably.
Yes, it could. Yes.
Presumably you could have a HTTP and that.
Yes.
I think that would be interesting to explore. I think we could to be able to try solid on top of that and try this on top of so in a way, it's all about people. Because a lot of people who are not, you don't see something.
Yes. Yeah, well, you're absolutely right.
It'd be good to separate.
Yeah, yeah. The unwalled garden spec could absolutely run on HTTP. And that's definitely a goal, to make sure that it was not baking in too many DAT things into it.
Do you identify things within the file, or only is it, when a JSON file is about more than one thing, how do you link to that?
It talks about more than one thing.
Yeah, we're gonna have to move on to the next session.
Okay, happy to talk about that. Thanks, everybody.
Mr. Frazee, tear down that wall.
Our next presenter is Faraz, who is building WebTorrent, the first torrent that works on the web and in the browser, and he is bringing P2P to the masses with accessible WebRTC-based P2P protocols.
Cool, thanks. So I'm Faraz, I'm honored to be here. So WebTorrent is torrents on the web. And the point of this talk, it's a little different than my usual talks. I'm not going to be sharing technical details or status updates about the project or discussing new tech in any way. I'm just going to try and share some lessons that we learned. So I introduced WebTorrent at this conference called Real-Time Conf, and I sort of did it as an afterthought. It was the last slide I threw in at the end of a presentation. And it was very clear in the talk that this was an idea that I had just thought of like the day before the conference, and that no code existed. But I put up this slide saying, like, wouldn't it be cool if we could do this? And something kind of funny happens. Somebody in the audience tweeted it out, and so this was the first tweet announcing WebTorrent. This guy, Aral, who's a tech privacy advocate, basically tweeted this out to his considerable Twitter following, and they were all super excited to hear about it, except for there was only one problem. This is what the repo looked like. And I didn't cut anything out of the screenshot, so you'll notice there's no actual code. I'll zoom into this part here for you so you can see. So a few hours later, he messaged me in surprise and said, "All you have is a README? Dude, I thought you had code." And I was like, you could have looked at it before you tweeted it out. So I updated the README and I said, "This project does not exist yet," in big letters at the top. So it was a bit worrying at first, but I'm actually really grateful that he tweeted it out, because it gave me like a push out of the door, and I got a lot of encouragement and feedback from people about the idea. And I don't know if I would have built it if I hadn't gotten that initial push. So the first lesson I'd like to share is that it's important to share your work early and often. Momentum is an incredible asset that people, I think, undervalue, and having pressure, having people expecting you to release stuff is really good. It's good for getting a project off the ground. So. And having wins to celebrate regularly is really important, at least has been important for us. Another thing is this idea of worse is better. So I love this quote. It's often undesirable to go for the right thing first. It is better to get half of the right thing available so that it spreads like a virus. And once people are hooked in, take the time to improve it to 90% of the right thing. If you want to learn more about this whole idea, there's a great paper called The Rise of Worse is Better. So I recommend reading that. So the way that WebTorrent did this, and the way that we embodied worse is better, is we focused on releasing something that was useful to users today, even though it didn't really capture the full vision of the project. So the first thing we released was this CLI that lets you do BitTorrent on command line. So I want to emphasize, this worse is better idea doesn't mean that you intentionally write garbage code, but it means that you focus on providing value sooner rather than later, and you initially ship something that falls short of your full vision, and you do this intentionally. So you want your graph to look like this. If I were to visually represent it, you want to be the red line. You're going to be providing some value over time constantly, instead of sort of providing no value and then being like, one day we're going to have this amazingly useful thing. So lesson 2, provide value along the way. The next idea is focus on solving a concrete use case. Think about who your ideal user is. So for WebTorrent, we had a relentless focus on this one use case of torrents on the web. And you can see that immediately in action when you come to the website. We wanted to emphasize that the point of WebTorrent is to reduce the friction of using peer-to-peer technology on the web, and part of the way we do that is by the fact that when you land on the site, you're already participating in peer-to-peer technology. You can see the peers here, you can see the video playing, you didn't have to do anything. So insist on having a simple pitch. Show rather than tell. And if the user can't figure out what your project does from the part of the website that they see above the fold, then consider that your pitch might be too complicated. So yeah, lesson 3, solve one use case perfectly. I believe if you can do this, then you'll be much better off than if you try to do a lot of different things and you do them all in a mediocre way. I personally think that a lot of the dWeb apps that we're building today are a little bit too flaky because they try to bite off more than they can chew, and it makes this stuff really, not good for new users. Thanks. Okay, so the next idea, technical bets are multiplicative. So what do I mean by this? So WebTorrent faced technical risk from many different sources. You might think like, okay, maybe choosing JavaScript as a language is this sort of a bet that we're making, right? Maybe we used Electron, that's a bet. We used WebRTC, that's another bet. So the chance of WebTorrent succeeding is based on the chances of all these technical decisions being good ideas. If any one of these were a really bad idea, then the whole project would fail. So you might plug in real numbers here and say, what's the chance that choosing JavaScript would be a really bad, cause death? That's like 5% maybe. And you plug in all these numbers and you see the chance of us succeeding was 38%. So sort of, maybe you may disagree with the details here, but the general idea is to don't be so cavalier about throwing in random. Oh, what if we redesigned HTTP while we're solving this other problem? Think very carefully about sort of the bets that you're taking, because they can really affect the likelihood of success for your project. So that's lesson 4. Another one is to be very careful about prioritizing nerd concerns, as I call it, because the nerdiest users will demand nerd features, and if you're not careful, then the time that it takes to implement and support all these features will suck up all of your time. So we created this nice template to post on GitHub issues to tell people kindly, no thanks, go away. So another issue where we sort of made the right decision here, but it was difficult, was this idea of gathering telemetry. So telemetry means sending basic stats about an application, so you can learn things like how many errors are happening in the real world. And users run into errors all the time and don't report them. It's important to do this. But we had a little bit of fear of pushback from privacy purists. But honestly, no regrets that we shipped this, because we really got the error rate down once we started monitoring this, and this is really important. We have also stack traces as well. And this is our little version showing what versions people are using of this stuff. So basically, lesson 5, ignore the nerds. Listening to the nerds. I'm a nerd, but honestly, even as a nerd, I think ignoring the nerds is a good way to go. Listening to nerds made WebTorrent worse for the non-nerd users, and the non-nerd users are the majority of our users. Another concrete thing, this is some of the data we gathered. The way to think about this is like startups who are creating apps are hyper-focused on their active user numbers and how to get those numbers up. And in many ways, they take it too much of an extreme. They're sort of pathological in their attention to growth. But I think many dWeb projects make little or no effort to grow their user base or to even see whether their stuff is working, and then they complain on Twitter that everyone is using centrally controlled social media apps. And so I think this is pathological in the opposite direction. So generally speaking, if we believe that more users using our apps is a good thing, then I think it's not evil to care about trying to get our apps into the hands of more people, and to make sure that when they're in their hands, that the apps are working correctly. So the first step to knowing, to making things better is knowing how many users you have, how that number is changing over time, and whether the app is actually working. So yeah, the data let us make charts that were extremely motivating, like how many users we were having over time, and it didn't turn us into evil capitalists. It was just let us see when things broke, and it was really useful for us. So lesson 6, growth matters. And so I just want to conclude on a positive note. I think that the opportunity that we have is huge, and I really don't want us to squander it. And it feels like many of the efforts that we've been working on are on the cusp of finally being realized. And I just can't wait to hear more from you in the next couple days about the state of all of the various projects. So thank you.
We don't have time for questions in this session.
Okay, sorry. My bad.
Yeah, but it was also the last one ran a little bit, so
okay.
we're just like behind.
Fair enough.
But you should catch Frost after if you have questions about WebTorrent.
Cool. Thank you.
Nice PSA.
Oh, okay, cool.
Okay, so this is Josh. Do you need slides?
No, I don't.
Okay,
I don't have slides.
Josh is a software engineer and tech event producer for Angel Launch, and he's a 3-year decentralized technology ecosystem veteran with a background in software engineering and mindfulness, as well as advanced states of consciousness. the Transformative Technology Conference in Silicon Valley.
Thanks. So my name is Josh, and let's just take a moment. We're all coming in. I just got in like an hour ago. Just take a moment to settle into where we are right now. So if you can close your eyes for a second and just feel your feet. Just notice the sensation in your feet. Notice if it's hot, is it cold? Does it feel good? Are you wearing socks? Can you feel the floor? Okay, so that's the woo-woo stuff. Just get out of the way. You can feel your feet. So what I want to talk to you today about is decentralized news. And what we're really participating in right now in this conference is really news broadcast via live events. So what we're doing is we're learning about projects, we're learning about opportunities, and we're doing this in a really decentralized way where anyone can speak just like me. And my hypothesis is that we need better technology infrastructure for new communities that are forming like this one on how to broadcast and create news. And we need better business models that can disrupt some of the existing models in the mainstream news. So how many of us have seen CNN in the last month? So if you look at the mainstream news, it sucks. It's fear-based, it's mass production, and it misses what's new and what's good in the world. And so my ask for this audience to think about is how can we look at news as a community to create new and better ways of finding and organizing as a community. So I didn't actually have time to put together slides for this talk, but what I wanted to open it up was more of a conversation format about what, I guess the topic that I'm really interested in is purpose-driven news. So you have news by an organization or by community that's driven by a shared purpose around what we want to accomplish together. And so, for example, the previous talk you just saw was someone communicating news about a project. So what I'd like to do is I'd like to open it up for questions about what would it take as a community to create new news technology infrastructure. Yes, I'm back.
The question, just thinking about this horrific time we live in, there is stuff that is easily transmitted, like the illegal rights. And then there's stuff that will take enormous amount of work to do, like a government who worked in Maryland, Colorado, who went for 6 months against her editor's instructions to pick up the truth of the Epstein sex scandal. One of those is easy, and one of those is hard. It's the outcome that's more important.
So you're saying like investigative journalism around topics that affect...
Technology is making it much easier for writers to get a simple story.
So what do you think the role is of discernment and choosing what we consume in that process? Yeah, I'm asking you. What do you like, or for the audience in general, like, what? Please.
There's a WCC community who's looked at, and I forget whether it's looking at this issue about how do you build systems. So you're looking at problems, building filtering systems in communities which can operate by reviewing each other's stuff, and generally doing a more creating infrastructure and systems so that you can use more sort of grown-up academic attitude contributes.
I think it's credible web.
Credible web.
Yeah. Great. We'd love to see that.
Say that again.
Credible web.
So just to reframe the question, I'm kind of asking, like, what is the purpose of news? Like, is it for entertainment? Is it for...
Engaging in the news at all, right? Because most of it is more like female purpose or like signal news to your kids that you know about the news, but you're a citizen that is engaged. There's things that you can't affect anyways, or and right? So I think, and like, if you are actually trying to get information to people that is useful, or say, become more effective, and you could do it such that you make a newspaper that broadcasts information in part of a number of different factors. Because people make more quality, people affected by design, so that would be metric how to rank what is needed.
And so maybe like this concept of like ranking news is like a new model of how we might produce news and transmit it to people. So you have like. Yeah, so then the question for the group might be, who here consumes news at least once a day? Who would be interested in sharing, why do you consume the news? Like, why do you go to news? What is it?
Truth. Looking for truth.
Truth. Beautiful.
Predicting the future.
Predicting the future. Dopamine hit. So anyone else? Maybe two more.
Staying up to date with the industry.
Staying up to date with the industry.
Maintaining the level of anger.
Maintaining the level of anger. It's true, unfortunately, in today's culture, right? One more. Affirming your opinion. So there's a wide variety, but what I noticed is there's some. One more back.
Participating in 5 minutes game.
Participating in.
Never mind.
So there's a lot of reasons, but what I heard is there's some reasons that are about basically taking action in the world, updating our reality. There's entertainment. And my idea is that conferences like this are coming together to create purpose-centered news where we're using the news as a form of data about how we take action in the world, whether it's forming industry trends, whether it's seeking truth, whether it's understanding our reality. And so, how much time do I have left?
I think we're gonna have to.
Okay, yeah. So to wrap it up, if you're interested in decentralized news technology infrastructure, come find me. I'm very interested I'm a software engineer, so I'm actively looking for collaborators in the space, and come talk to me if you have ideas. Thank you for your time.
Okay, so because we got started a bit late this morning, we realized we have this cut off at 1 for lunch. Everyone wants to go get food, so I'm sitting in here. So we're gonna have to cut these down to maybe about 9 minutes, so everyone can cut the question and answer session so we'll get short on this. Alright, so next up we have Yisu, who
Okay, just
can announce some project.
Okay, do I have to
Do you have
introduce
a
myself? Yeah. Well, that's short. Okay. Okay. So sorry for the theme. So yeah, I didn't choose this one, but our designer chose this. And oh yeah. So let me do some brief introduction of me. I'm Yisu. I'm from China. We are a startup in Shanghai, based in Shanghai, China, and then our company is called Dimension. So yeah, let's talk about today's topic. It's enhanced privacy with decentralized identity. Sorry, it sounds fancy, but it's not that fancy. Okay, so first, what is privacy? It's basically just our fundamental right, because it's we own this right since we were born. And our privacy is compromised. Well, the answer is really obvious. It's yes. And then what happened? Well, everybody knows about the Cambridge Analytica scandal years ago, and we got many data breaches in many in many companies, those giant companies. We got our data was compromised. Our privacy was compromised. We don't want this to happen again. So we got this. So next, what is identity? So identity is pretty a common character in our daily life. So identity is qualities, beliefs, personality, looks, or expressions that make a person a group. So that was quoted from Wikipedia, and we're basically talking about identity as social identity. It's how you look like in society. It's your name, your gender, your nationality, and your occupation. It is verified by the government, and then we all look alike, but we identify each other by these characters or characteristics, like these images there. And then now we're gonna talk about the digital identity, which is the core stuff we're talking about today. So your digital identity could be a Facebook account, a Google account, a Reddit account, and all of these are verified by third parties
not for by the government, but by the third-party organizations like Facebook or Google. So we got some really serious problems with these like digital identities. So the identity can be a key enabler to our privacy. That's a fundamental thing to our privacy. Without identity, we don't have privacy. And the user's identity trust is largely dependent on those like third-party organizations. Our trust is basically dependent on Google, on Facebook, because we're posting there, or we're using their like account to verify the other things. And users need to register multiple accounts across different like platforms. And the identity providers are having too much access to our information, to our privacy, but they I don't know, but they accidentally leak a lot of them to the other companies across the other organizations. But they're supposed to protect our privacies instead of doing something harmful or something like evil to those. So we have like some current solutions to that. We got a password management tool, which I don't think it's a really good solution because users only need to, but the true thing is that users only need to create one master password, one like strong password, and then all of your multiple accounts are protected, or the passwords to those multiple accounts are stored in their database. You can just always access them with that master password. Sorry, it's just too bright there. So but we don't have like one unified identity or account there, and all data is stored on their cloud, which is still not that safe. And this is how it looks like on one password. So you store all of your information in their app, in their cloud. You just need to remember one master password, then everything's stored there, securely. And the second solution, I guess, is OpenID. So such as Google login or Facebook login, they're all part of the OpenID standard, but just Facebook login might not be there any longer. But yeah, seriously, they just access the OpenID standard. They got their own Facebook ID or Facebook login. So that's they have like a unified identifier or identity on the web. So you just need one Google account or one Facebook account to log in the other supporting platforms. And there's also a single sign-on product, so you just need to sign on once, and then you authorize all of the others. And your trust is dependent on there. So your trust, if you have a Google account, your trust is dependent on Google, and so does Facebook. And it could be vulnerable to multiple attacks due to their like low-level security design. Like since this was designed like 15 years ago, it wasn't like on a really high like security standard. So we also have like we already talked about these two like solutions, and the other one could be this is a really new one. It's called Decentralized Entity, which will be talked a little bit more today. So with Decentralized Identity. So what is it? So it is a digital identity, still a digital identity, but could be created by the users themselves. And it can be verified without a third party and nor a government. It can gain enough trust to prove your identity. And users can decide which part of their information or privacy to be shared with which parties. And users own and control their own data. So 4 minutes? Okay, gosh. I'll just grab it quick. So where's our trust? So I was supposed to talk about some like existing decentralized identity solutions, but I just have like too few time. So yeah. So where's the trust behind it? So we have like blockchain or more generally distributed like ledger technology to store our information. So the trust is built upon the globally distributed ledgers or decentralized P2P networks. And we call it the trust of mathematics because you are creating a cryptography identities, create cryptography key pairs to protect everything, to prove you are someone or some identity. So with the trust, but we still don't have the privacy. So the idea is limited control from third party over users because you like create it yourselves, but the data is still being collected by them, and it cannot solve the problem with data surveillance. So we're just I'm just gonna like talk about some of our products. So we have like 2 solutions to this, and I will just briefly talk about them here. So we have like privacy insured social network solutions and privacy insured instant messaging solution here. So the first one is called Massbook. It's a web extension. It's already on Chrome Web Store, but our new update was rejected by Google for no reason. I don't know why. But so each user with an unified identity, we used the SECP 256K1 curve because it was largely used in most blockchain systems, and you can create encrypted posts that only your designated friends or recipients can decrypt. And our slogan is hide from no one but Facebook. Okay, that's by now. And why Massbook? So we have like this just rhetoric things. We're gonna skip it. And then we're probably using GunDB. The founder is also here, Mark Nadal. Apple. He also have a talk later, I guess. So you guys can take a look at it. So this is a really brief technology overview of our product. So if you want to create a post on Facebook, just type the hello world. It's the same thing. It is encrypted by AES-256 key, and we will post it on. That's what you are gonna post on Facebook. And out of your like the one who encrypts your post, the AES-256 key was shared by GunDB over there. So we're using ECDH. It's a really cool like algorithm or designed like years ago, 20 or 30 years ago. And then, sorry, I just need to wrap it up really quick. So if you need more details, just come to me, please. So our next solution is called TestCube. What is a TestCube? It's a mobile keyboard enabling users to send encrypted messages to a friend. So this is one example. So if you type something there, and then you just click that button here, and then you choose the recipient, and you choose it, and you can encrypt it. So we're now using PGP, but we're switching to ECC solutions later. So why we're using TestCube? With TestCube, we can enable end-to-end encryption communication everywhere in all of your apps, in all of the platforms, on your mobile phones or on a computer. So how does it work? So we're now using OpenPGP, but we're switching to ECC. And so sorry, just Jay's staring at me. So why we're okay, I will just wrap up real quick. So we call it Decentralized Entity because we use a ECC key pair that you can create by yourselves, and then that qualifies what I said before on the Decentralized Entity. And in the very end, I would just want to talk about like crypto anarchism. So that was like introduced like 30 years ago by Timson May, but I'm gonna end now. Okay, this is not real anarchy. Please. This is not real anarchy. We want to use crypto to hide from the government, hide from the censorship. We want the utopian behind all of these like evil or things. Okay, sorry, I'm being evil. And then check out our website at here. Okay.
She's later to talk about Massbook and crypto anarchy.
Oh yeah, thanks. Actually, we have TestCube, but yeah.
Oh, TestCube too.
Oh yeah. Thanks.
Is Duncan here? Duncan? What about Sergey? All right. Sergey is the director of crypto economics and blockchain systems at Perm State University.
Hi, really honored to be here, and yes, actually, thanks for setting me the stage about the decentralized identity. So I'm going to talk about the.
Take the back.
Yeah.
Okay.
So, I traveled actually to talk a bit about our new idea how we can build the identity protocol, which is ensure the uniqueness of human. And why do we need that? Actually, basically, in the open systems like the blockchain, so you could have civil protection to make decisions collectively, and this is fully on governance. And now it's based fully on the capital, so basically we work with the state, and it leads to kind of to plutocracy, like a power of wealth. And ideally, we need some kind of a different basis, which is the identity of humans. So we want to build the voting based on the humans, one person, one vote. Another use case is if you have the network, which is we make sure there is no signals, there is no bots, but every, let's say, account is human, no matter like who it is, just a human. You can potentially have a new model of the information delivery and advertisement. So, like, I can send you an airdrop, and you are a human, you can use it and get paid directly for your attention. So it's a new model for the finance and the internet. Then, as you mentioned, like serverless messaging, you can have peer-to-peer encrypted messages, which are stored by the whole network in delivery, and then get delivered unencrypted on the peer. Or you can store your unencrypted message on the node, and you have kind of publication platform, which is free speech, so nobody can come and censor it. So no government or no corporation. And finally, at least it's the UPI. So essentially, you have a global way to distribute the wealth, whatever it is, to the utility, just to humans all over the world. So this is the kind of quicker target. And probably like, why don't you just take an existing identity? Like, for example, social ID, like Facebook or Twitter ID. That's not a good idea because it's centralized, and Twitter can ban your account, and then you're out of the network. And it's also easily faked, like Facebook. I think they cleared like 2 billion fake accounts in Q1 this year, and it's actually growing like crazy. You can buy the Twitter accounts for $10 per 100. Then there's the government ID. Actually, potentially you can ask people to go to KYC and ensure they are unique humans. Also not a good idea because there is no global government ID, public infrastructure. It's centralized, of course, and it's not inclusive because at least 1 billion people have no government ID still. And actually, it's over and world, you're easy to be surveilled if you sign in with a government ID anywhere. Biometrics, or like DNA, this is not a good idea as well, because this relies on some specific algorithms of processing biometrics and ensure the hash of your biometrics information. And the problem is that, for me, the big problem is as well, you don't have a plausible deniability. If you do something, then it can be actually also traced and prove that you did something like that. And more perspective is the self-sovereign identity, like DITs. But the problem is that they mostly rely on some existing verifiers, trust verifiers, and this is the problem that the government ID and social ID is going to be the same. You have the same issues then. Web of Trust is now being rebooted. It's been improved, to be protected from cyber attacks, but it's still the big issue because it's an open system, and the open system can be easily cyber attacked. You can create fake friends, and you have network of which controls suddenly the whole Web of Trust. So what the design properties, what we're trying to achieve is the same problem inspired by Bitcoin, to have a decentralized way of be verified, global, so permissionless, decentralized, and civil protected, and anonymous, preserving the privacy, censorship resistant, and without external reference to any existing ID. And the solution that we kind of work on is the proof of identity blockchain, where you can create a kind of it's based on the massive online time-synchronized collective Turing test. So we all at the same time, actually, tomorrow at 6:30 a.m., it's going to be the next one, we all kind of solve some AI hard problems, like some puzzles based on the images, like CAPTCHA. And collectively, we validate, if we pass the test accurately, validate is human, and because we do it at the same time, we are unique, so there is no like no problem of kind of double or spending, like have several databases by same person. And decentralized, so there is no single server, no single kind of central party which issue those tests and kind of validate those tests. So it's like we collectively self-validate. This is how the AI hard task looks like. You first, when you create such kind of a task, you need to create a story which has like some common sense reasoning here. For example, this is the vase, then there is a cat, then there is a wet floor and a sponge. So like, and there is another sequence which is wet floor, sponge, vase, and the cat. So what do you think? What's the reasonable story? What's kind of what happened here? Is it the left one or the right one? So left, yeah. So probably 90% will answer the same. It's kind of what could happen in the real world because there was some sequence of events. And people are getting really good of making those captures and solving those captures. On average, is 90% accuracy. And AI are really bad at this because there is no common sense still, and there is no general AI which has the spatial reasoning, the causality reasoning, and kind of all this thing that humans still have in creativity. So yeah, I mean, I still limited time. So tomorrow at 6:30 a.m. there will be a validation session. So please join if you're early. So yeah.
Where will that session be?
Yeah. Where? Probably at the breakfast. So thanks, and I can question.
Yeah, yeah, questions.
So how do you ensure that the challenges that people solve are truly synchronous? Because there's going to be some skew if someone comes in at 6:30 and someone comes in 6:30.
Yeah, there is, because it's a peer-to-peer network, somehow you have peers and you synchronize all the time. And it's, you don't have to be exactly at the same time. It should be like, you have 5 minutes to solve like 5 flips. Probably you shouldn't give that time, but it should be the same time for the whole people nerves, because otherwise you will have 2 or 3 or more.
Yeah, but what if you've got 2 laptops sitting next to you?
Yeah, if you're really fast, or kids are fast, solving those, you can probably solve 2, but not 10 or 1,000. Yeah. The test?
Yeah, who controls the test?
The test, actually everybody. So as soon as you get the validated, for the next round you prepare your own flips. So actually you've been granted the 2 words randomly. You need to create a story about, let's say, a figure or in the rural area, the country. Then you go and kind of try to find some pictures, not to make them on your own cell phone or just kind of Google it. There is a flock of bird, there is a farmer, then there is a squirrel, and there is a frightened bird. It was my task yesterday. And then I also shuffle it. I have the right sequence and the left sequence is shuffled. So the way is not logical. And then I publish it and that somebody else will solve this in the next round.
Okay, it's like a lot of questions.
Well, typically the cultural bias is present and the work of white people, they may not even work black people now, but that's the story that they have it.
I mean, yes, of course, yes. You cannot use the, for example, language capture because it's English language bias. So you need to, image captures for our case is more or less universal because it's like images and it might be that you don't have enough cultural experience to solve particular capture, but in general we have some kind of common sense in globally. So we hope that it will be kind of universal.
Really about spending less time programming as opposed to like defining problem space and then solving for that, right? But yeah, sorry.
I think we only have time for one question.
Oh, okay. Talk to you later.
All right, so is Duncan here? Right. If Duncan doesn't show up, we can do questions at the end. Rodney?
Why don't you say who's on deck?
just so that.
Who's on deck for the rest of the session? Okay,
Why
so
don't you take questions until the other
Some ways of knowing that, okay, I'm sending a message like in this kind of community, this kind of people come in, of course, but the answer is you can't design for everyone. Like, so if you're building a product for newbies, then of course cater for the newbies and make sure that that use case supported, but that means that very advanced power users are probably not going to feel catered to at the start, and vice versa. So, yeah, you've got to define problem space first and then respect the users.
All right, everybody, my name is Rodney. I am with Woke. And what I'll start off with is that Woke is building what we call trustless HTTP, so kind of a blockchain for storage in a decentralized manner. What I will do now, which I hope it will just scroll over, is I'm going to do my best Brewster Carroll's impersonation. He often does this, and you say, hey, we got the decentralized web, and we go to the site, I got it up here, so this is lightning talk, and when you look over here, he prays to God, and he's like, oh, come on, load. Yes, I am praying now. And that you will see all this stuff happen that shows that HTTP, IPFS, WebTorrent, and ASS Woke are loading and fetching data in a decentralized manner. I am you for the next 10 seconds, okay?
But this time it worked.
Bring me along with you whenever you so I bring that up to say Mitra is the developer that did most of the check-ins that you might see on GitHub. And we said, hey, we want our name up there on one of those green buttons so that we can have our data stored. Then we can help, partner with you to do the decentralized web of the future. And so he sent me a link, which this will link to, and we can share. It says, if you follow these instructions and check it into GitHub, and we go through, your data will be stored there. And as you can see by the green dot, it is there. And so what I'm going to show is very much the same demonstration. What we did is we just took it to try to make it really unique. Is we took Paul Frazy's Beaker browser, we forked it, and then we put in this case, to make it simpler, we just put in a kind of a Woke transport layer. But because we loaded up the dApp inside of our, which you might call it dApp, it has the same functionality. And so what I will do is show that in our browser, we also only use the Woke protocol. And so what it's doing is, you can see it's using Woke //. So there's a gateway essentially, and I'll give you like a quick review after this, where you can set up a node, or you can go to a node just like anywhere else and access data that is stored on our decentralized network. And so what we've done is we've taken a bunch of the Internet Archive files and created something with the help of Mitra to, anytime there's a request for something that's not yet stored with us, it gets stored. And if you can see here, when you refresh, I am now praying and praying and praying, and you can see that there's different things happening in the console in there, but you see the same thing is happening here. Now, that's not as impressive as you might think, but what it does is you can also turn IPFS off. You can do this in the other browser, though you're showing that we can do it as well. And if I can go over here, you see IPFS was being fetched. And now, if I come down and I want to pick up some community images, this page loads. This is all loading without IPFS anymore. So if you could go through, you see no more fetching, right? So you turn it off. And the idea that Mitra and I think the decentralized web, and I think all of us should have, is that you don't necessarily need to build a dApp and have it be reliant on one storage area, either storage network or provider. You as a developer, or you as a user of a dApp, may want to choose where your data is stored. You may have a place where your data is stored, and so you can control that in this Internet Archive dApp by turning on and off these various toggles to make that happen. So that's the key. The key piece of this is that you have a multi-transport layer. And so what we want to do, and we're going to have more of a deep dive at 4 o'clock, is to find other providers that may want their name under, have green dots that show that, and build the multi-transport, but have some sort of consortium, some sort of group that says, what if we can make, just like there's Web3 that just got into the Opera browser, what if we had a decentralized storage, like a storage.js, or storage Web3.js, that dApp developers could just put in, follow this common protocol, and have data be stored and retrieved in a decentralized manner. So that's the kind of vision that was started by us working with Mitra to say, oh, you can just turn these off and on. I can use IPFS, I can use WebTorrent, I can use Woke, I use Gun, all these different storage providers, but it gives power back to the users. Also, you could be a developer and say, my app actually doesn't need these other ones, but it does need these 2 or 3. And so you can kind of enable the ones that you want, and then the user can turn them on or off or whatever, which has these intelligent defaults. And so this slide just kind of talks about what we're doing. The reason why ours is different is that we just basically took HTTP posts and gets, and they're signed. And so anytime you make a HTTP request to post data, like I want to upload my driver's license for some ID verification, and then when I retrieve it, it comes back with a proof. And so you know that if you know my public key, you can be assured that I'm the one that created that transaction. And so that's the uniqueness that we can talk about also at 4. But what we did, again, is I had to take those HTTP posts and gets and follow what Mitra's details to the spec to how do you set up yourself, how do you store bytes, how do you fetch bytes, how do you store a key and a value, how do you retrieve a value, how do you delete. And then there's other things that we haven't done yet, like video, where it's range requests, and those types of more complicated actions. But there are dApp platforms and browsers and extensions that are already doing a lot of different interactions with IPFS or Woke or Gun or these other storage providers, but they're not necessarily consistent. And I think if we have a development framework where we can have all of us come together and decide what actually should, at least at a minimum, be required, it will make for a lot more seamless integration for the storage of data and retrieval of data. And then we might get the dApps that have more than 100 or 1,000 daily active users, because it's cut down and we've kind of progressed the mantra of saying that we, the users, and we, the developers, can take a little bit more ownership over the data and the way that the data is interacted with. So that's really what this talk is about, is saying if there's anybody here that is interested in that, we'll be talking at 4. So I'd love to hear if there are people that say this is a terrible idea, a great idea, or want to be a part of it at 4. I think you had a question?
I was just going to say, I wasn't trying to interrupt, but I was going to say, you definitely are, and I think local storage is actually the place where open standard view-based users and information can be controlled by the user security.
Okay. You said local storage?
Yeah, local storage, and also annotations and any standard. That's all I'm saying. I'll definitely move in forward.
Okay.
That's what
Any other questions? Is there?
I'm sorry, but I'm looking for Mark Nadal. It's not in this crowd.
Not Mark Nadal.
I know who he is, but is anybody? Yeah, he's. Oh, got it. Thank you so much.
Any questions? Anybody would be interested in talking to us at 4?
Yes.
Okay. Else? Okay.
The overweb.
Overweb. All right, I got you. I downloaded Bridget. So all right.
Thank you. We also see Dietrich in, who's supposed to be earlier.
Cool.
Yeah. All right.
Thanks. No one.
I've got a little bit shuffled here in the schedule, but this is Dietrich Ayala, who's going to be talking about super browser, true user agency, and a dWeb world.
What does it even mean?
Can you hear me in the back?
Yep.
Okay.
So Dietrich is a developer advocate at Mozilla.
No, not anymore.
Oh, okay, never mind. Just
Super
updated.
old.
I will let him introduce himself.
All right. Hi, my name's Dietrich. I was a developer advocate at Mozilla. I was there for over a decade working on Firefox and other related projects. And I'm going to mirror my screen today. See if that works. There. Hey, yes. So I've been working on browser stuff for a long time. I feel really lucky to be here today with you. Do you all feel lucky to be here? It's a pretty amazing event with a stellar group of people. We have an understanding here, probably more than most places, about how to communicate directly without intermediaries, how to communicate in a way that is maybe more censorship resistant than other people. That makes us really special. That makes us kind of like a privileged elite, because most of the people in the world do not actually get to interact digitally online together that way. They use technologies that are not decentralized or not distributed and don't really have a good understanding of what they lose by using mass adoption at scale systems. So most of the world is using systems that we here often kind of disagree with or have a problem with. And our size, statistically, is pretty near zero compared to all the rest of these people. Most of the experiences that people have online are usually with big brand names, very large companies, some of these that we actually even like and use every day, but don't offer the type of capabilities that we're trying to build here as a group. The nature of what a user agent is has kind of changed since its original definition, just to fetch and display content, and maybe I think there was actually some equivocation there. It initiates a request, maybe it completes it, I don't know. But the nature of that really changed. We started to use browsers as full applications, much more sophisticated applications. This has resulted in some issues: censorship, surveillance, even like your favorite website changes a design or theme or updates the version, and that really makes every day painful for you because you love the old version so much. And basic things that we still can't do on the web. Like it's very, very difficult to, using a mainstream web browser today, share a file directly to you without some type of intermediary that involves a whole lot of these problems. The browsers that a lot of people in the world use today aren't really making a lot of progress on adding these types of capabilities. If we could add any capability that we want to web browsers, like if we could add IPFS or that, like what would that browser look like? What would your ideal browser look like? One that represented you, that actually had values that you have built in, that it had censorship resistance built in, anti-surveillance built in, or allowed you to share information directly to somebody, a member of your family, which is often very intimate information, without any intermediary, without having to go through some third-party server, or even go through a server that you might run, really adding to the overall complexity and overhead of running services. What would your ideal browser look like? It would be perfect. It would have all these things. We'd be able to share directly. We'd be able to not worry about who's watching, or would we? It's often not that simple. You trade things off. You own your data, but then you also might lose your data. Owning your data has a super high overhead cost of maintenance. It's really technical barriers as well that people have to deal with. If you can communicate like nobody's watching, it turns out it's harder to make friends. It's harder to find your people. Sometimes even here, where we're sitting around scanning QR codes with each other and hoping that in this complex stack of things that actually results in a maybe direct connection between two people, there's a lot of challenges in building these things. Even when you might get one feature in the dWeb, but that means you give up another. I can publish something immutably that nobody can take down, but the downside is that it's there forever. I might change, or that might present risks to me that staying published. So there's trade-offs. There is no perfect browser, I think. There is no utopia of dWeb. There's different use cases, different trade-offs that we have to make. And those trade-offs are some of the questions that browser vendors that we know today are asking. One of the reasons why it's so difficult to change the surface, the API surface area of the web as we know. why the time scale of adding new features to a web browser is really, really long. Because they're making these decisions based on the needs of millions, and sometimes, in the case of some web browsers, billions of users. We have the privilege of being able to build things for ourselves. But those billions of people are really, the features that they have that in their hand, in their browser, are restricted by a really small set of companies. But there are some new browsers and new approaches coming to light to build these things. I'm going to talk about a couple really quick. Brave is a browser that you likely have heard of. They're adding IPFS into their browser. You can load in Brave nightly right now an IPFS URL, and it'll prompt you to install IPFS support. This will connect to an IPFS gateway, so it's not actually a full node, but you can actually even flip that on so that IPFS, a full node, is running natively inside Brave. It's hopping on some Chrome OS APIs to be able to do that, which is kind of interesting. Puma is another browser, and I think Yuri is here today. If you want to ask questions of him later, this does some interesting stuff as well around content publishing and mobile browsing. Beaker browser, which you've also probably heard of, Paul's here today, is a browser that supports the dWeb protocol plus some APIs on top to be able to give you more capabilities. One of the ways that you can do these things are with browser extensions. Now, the browser extension surface area is pretty small. You can't do things like OpenTCP sockets or listening sockets or UDP or things like that. But you can connect to locally running instances through native messaging. So Patchfox is a Firefox extension that allows you to communicate from Firefox directly to your running Scuttlebutt instance. One of the projects, web extension land, that I worked on last year with Rockley from Mozilla was libdWeb. libdWeb is an experiment that gives browser extensions some of these super boring, low-level networking basics and file system access, but the combination of these things allows you to turn your browser into a full node participant, so two browsers can communicate directly to each other. One of the members of the IPFS team immediately took that, got IPFS running as a full node inside Firefox, and got Turkish Wikipedia running, a place in Turkey where Wikipedia is banned and not allowed. So you can load Turkish Wikipedia through Firefox directly and serve that content to other Firefox users when you have these experimental extensions installed. So really, really powerful use cases there. Electron is another way that people have been using to be able to build their own browser. Beaker is a great example of that. You can publish, you can share, you can own your own data, you can make decisions. One of the challenges of things like Beaker is that you can do whatever you want. You can add anything in there, which sometimes leads to a variable user experience or different levels of complexity, but you also have to install an entirely separate browser. So there, again, some trade-offs. You can load a .url natively, which is pretty amazing. Frame is an Ethereum client based on Electron that you can load as a sidebar, and I've been hacking that to build my own single-host browsers that run on the side. Mozilla Reference Browser is an interesting way to create a mobile browser that can have dWeb capabilities. It started out as a set of components for Android. They put those components together into a browser that anyone could fork, and basically does all the basic stuff that a browser needs to do. And then you can bundle extensions into that. And this is an example of opening up a .dat URL in a mobile browser that has both libdWeb and .dat support in it from people from the Plex project. So you have a full mobile browser that can load .dat natively and can actually act as a full node. So you could actually serve data directly from that mobile browser that you're running. This was because that reference browser project allowed them to bundle their code in just one line. So for this mobile version of Firefox, they just changed one line to be able to bundle their code in, and they shipped a dWeb-capable browser. The challenge is that these are the control points of this feature surface area, is that the browsers, the mass market browsers that we have today, have a lot of things to worry about. There's a lot of risks for them in shipping risky features, in, say, expanding what they see as the security surface area of the web today. They have the responsibility to take care of millions and even billions of users' experience on the web. The trade-off that they have to make is that they cannot take these type of risks when adding features to the web itself. But what these pathways have shown us is that there are experimentation vectors for these types of features, that there is a way forward, And I think this is the question that I want to leave you all with is the era of the general purpose web browser at an end? Are we at peak mass adoption browser when the biggest browser of all is being called a surveillance vector by the Washington Post? Maybe we have reached peak browser and we have our own use cases and need to push on building the browsers that we actually need for our needs. Thanks. I have a session at 3, and I know there's a lot of lightning talks.
Okay, great.
So find me at 3 o'clock in the mesh hall. Thank you.
Any questions until he's got those?
Let me take the question.
Okay. All right.
Go to the side so we get
Go
set up
side.
Yeah. Leave him.
Got it.
Go to this side. Oops. Take questions until he's got his feet.
Sorry, I was standing outside the room for most of the time. I didn't know the process.
It's a new
We just created. Hey. All right, question in the back.
Yeah. So we can imagine a world where you have 25 protocols doing their 25 dWeb demos. We kind of did that for a world where we took the Beaker browser and forked it to demonstrate stuff. Or you could have a super browser which has 25 protocols. Now, what do you think the dWeb community should be doing to build a super browser? Is it 25 browsers with their one protocol, or is it going to be one super browser to understand lots of dWeb experiments?
I honestly don't have a good answer to that. I mean, that's why that question's open at the end. I don't think there's going to be a one-size-fits-all browser. I think the use cases that people have are really, really, really different, and different from geography to government and regulatory regimes to the relative kind of personal risk of how you use the web. I don't think there's going to be one single answer for all of that.
Great, thank you. We've got 25 minutes till lunch and a few more talks. So.
Cool. I'll be quick. So hi, Adrian. I work for a company called Coil. Previously at Ripple, where we developed this protocol. I'm all the way from Cape Town. Jealously watched my colleagues attend the last few dWeb events. So I think I'm probably from the place that is geographically the furthest from where we are now. Possible, I think. Challenge. See if we can find someone who's from further away. So I'm going to give you a very brief high-level rundown on how Interledger works. At the end, focus a little bit on the applications for the decentralized web specifically. So let me start off by saying, what is Interledger? It's a payments protocol. That's what it is. It's a 5-year-old project. We started this at Ripple. 2 of my colleagues published a white paper on this, I want to say in 2013, 2014. And we've been running as a community group at the W3C since then. Recently established a foundation to hold all of the IP. That's sort of the project side. But Interledger is a protocol, a stack of protocols at least, but at its core is this protocol, which is very similar to IP, heavily influenced by the internet and how the internet works. And its goal is interoperability. What we use Interledger for is interoperability of existing payment networks using the same pattern the internet used to connect existing networks. So in as much as IP provides an overlay or an interoperability layer on top of Ethernet and Wi-Fi and so on, Interledger operates over existing payment networks or new payment networks to allow people to move money across those networks. How does it do that? So we have a protocol which, like IP, has packets, and effectively packets are routed through peers from Alice to Bob, and we call those peers connectors. But what's important is that following the exchange of packets, there's now balances that exist of money that's owed between peers. So if I pass a packet to somebody, they pass it on, and that packet ultimately is completed, and I'll go through the completion, how that works. I now owe that person some money, and if they send packets to me, they owe me money. We eventually net out, what's the net balance between us, and according to some schedule or a risk-based decision, we settle with one another. And so you can set up those peering relationships based on how much you trust your peer, how much money you want to, how much exposure you're prepared to have to them, and you can settle once a day, once a second, every packet. All of that is determined by the risk that you feel exists between you and the peer, as well as the capabilities of the underlying settlement network. Obviously, it doesn't make sense to settle over PayPal every 5 seconds. Yet, if you're using Lightning, you might do it more and more often. If you're using Bitcoin directly, you would probably change your settlement regularly. Packets are routed using an address, so very similar to an IP address. ILP addresses are also hierarchical in nature, just like the payment network. If you're familiar with using a payment card, the primary account number, PAN, on your card is how your transaction gets routed. You swipe your card anywhere in the world. If it's part of one of the big global card networks, that transaction gets routed all the way to your bank to authorize that payment. Very similar process to IP. With ILP addresses, we've made them variable in length, which opens up a lot of very interesting possibilities. The execution of an ILP payment is very similar. In fact, I think there's a reference to it. Very similar to how payments are done on Lightning. Every payment consists of a pair of packets, a request and a response. So the first is what we call a prepare. So we prepare the payment and then we commit it or execute it. That prepared payment contains a condition, which is just a SHA-256 hash. And the fulfillment contains the pre-image to that hash. Now, the reason we do that is when the payment is set up, when the relationship between the sender and receiver is set up, there's various protocols for doing it, but there's an establishment of how will the fulfillment actually be generated. And in all cases, only at most the sender and receiver know how to generate that fulfillment, the pre-image. In certain cases, you may have a setup where only the receiver can set up can generate the fulfillment. And so what that guarantees for the two of them, as the sender sends off the packet, when they get the response back containing that pre-image, they know that the payment got all the way to the recipient. That's the guarantee they get. The only person who could have fulfilled that payment is the recipient. And for everyone along the way, it's used as a trigger to consider payment complete. So we have 3 packet types: prepare, fulfill, and reject. If a prepare payment hits a node in the network or even the recipient who is not prepared to fulfill the payment or is unable to, it gets rejected. So a packet contains an address, we've covered, a condition in the prepare, as well as an expiry. And so the basic rules of the protocol are: I send you a prepare packet with an expiry and a condition and an amount of money I owe you. And if you send me back the fulfillment of that packet before that expiry, I owe you the money. That's ILP in a nutshell. It may look familiar, hourglass architecture of the internet. As I said, heavily inspired by that. So where are we in terms of development? ILP, the core internet moving protocol, is complete, pretty stable. We're at version 4. We skipped 2 and 3 along the way. They were bad experiments that didn't make it out of the lab. That's probably been stable for about 2 years. Stream is a really interesting protocol that builds on top of it. So inspired by Quick and other work at the IETF around transports, Stream leverages that same idea and allows you to establish a packet switch connection with an end party. So knowing somebody's ILP address and a shared secret that we establish between each other, I can open a packet switched payment connection with them and send ILP packets back and forward. And what the protocol allows us to do is for me to understand from them how much they're actually receiving when I send a packet, because obviously as packets travel along, people can add fees or apply exchange rates and so on. So I want to know when I send that packet, in the response they send me back how much they actually receive. And I can even say to them, don't accept the packet if you receive less than a certain amount. So the stream, the simplicity of ILP is exactly the same as IP. Super simple. There's a great blog post by Evan on all of the features we took out of ILP, and a lot of that stuff is moved up into the transport layer, which is much more sophisticated. How does this apply to the web? We're building really awesome things at that layer. So once you have this ability to establish packet switch streams between entities that move money, move actual value, you can build amazing stuff. So at Coil, we're focused on micropayments and monetizing the web. How do people earn revenue from services or content or whatever that they provide on the web without having to just rely on ad-based model. And this is obviously, I think, I'm speaking to a well-informed audience here. I think you'll appreciate the many benefits of being able to earn revenue online and not depending on ads. 3 question marks in there, could be 100. There are so many use cases for what you could do if you're able to move money simply in this sort of way. So where money is effectively streamed in the same way as data would be over TCP/IP. One of the features, or one of the things that we do with ILP, which I think is really interesting, is if I, for example, want to pay somebody $10, instead of sending them a single packet for $10, I send multiple packets, I stream them multiple packets for smaller amounts. And what that means is potentially those packets could be routed different ways. We can change how that payment is made to accommodate risks, change varying exchange rates and so on. So it's really feels, for someone consuming the stream interface, feels a lot like a TCP/IP bound stream. Last but not least, we came up with an idea for sort of a discovery pointer, something that will allow you, as a regular human being that needs to exchange and identify for your account or for a specific invoice or for something to initiate a payment, with what we call a payment pointer. So we took some lessons from people trying to use URLs for identity. One of the big problems with WebID is when your average user doesn't understand about using a URL to identify themselves. Email addresses are a terrible way of doing identifiers because they're email addresses, so overloading an identifier is hard. So this is a really simple algorithm for taking something that is actually just a URL, but made to look slightly different and converting it into a URL. And that kicks off the process. I think that is it.
Before we take questions here, I want to check to make sure some of the people seem to have not come to the session. So is Duncan in the room? Okay, Margaret Warren? Okay, great. Evgeny Ponomora?
Yeah, there are a couple of seats still around.
Michael Brezel? Maybe we'll do questions or something like that, but you have to sign up in the lightning talk box for talks with Paul. Yeah. Okay, so it looks like we're missing several people. We might have Margaret Warren, but why don't you take some questions while
Sure.
I go find
Sorry for breezing through.
So the overlay with IP is end-to-end, which means that the origin and the final destination are knowing participants in the TCP/IP world. And this is done by taking uninterpreted bits of the payload of the underlying layer and then putting the IP, or as you go up the stack, protocols. I'm unclear with what you're describing here, where the uninterpreted bits of the underlying system exists.
Right. So there's a difference there in the model, IP versus ILP. So let me be clear. So in the very early days, what we had anticipated was that your ILP packet would be inside the metadata or something of an existing payment on a payment network. And what we found was that means you're reliant on the performance of the underlying network. You can only send one ILP payment for every payment in the settlement network. So here we differ again from IP, where we say, I send you a packet. It's not wrapped up in a payment from the underlying network, but we exchange packets back and forward, and at a point in time, we make a settlement on the underlying network. So that architecture.
So that doesn't sound like an overlay. That sounds like a parallel system.
Say again?
That doesn't sound like an overlay. That sounds like a parallel system.
Fair enough. Yeah, you mean it's not an overlay on top of that existing payment network? Yeah. That's fair. That's fair comment. It's not an overlay on top of the payment networks. It's an overlay on top of the internet in some respects. It's a network built, but the settlements happen between peers effectively in the same model. Perhaps the wrong use of the word overlay. Okay. Oh, sorry.
Can you explain a little bit the motivations into splitting large transactions into small packets?
Sure. So one of the early challenges we had is we had a quoting protocol. So what you have to do obviously is I'm sending this payment that's going to go through potentially multiple intermediaries, and they're going to, I'm going to send a packet denominated in dollars, send you, $1. You're going to pass it on, but your settlement arrangement might be denominated in Bitcoin. So you're going to apply a conversion, and it could also be dollars. So you might take a fee. So the amount you send out may be different to what I send, basically. So there's a rate of exchange that's going to happen between me and the recipient. So we used to try and quote for that. We used to try and basically set out a quoting protocol. And what we found is that's really problematic. There's no guarantees, for example, that the payment will follow the same route as the quote, etc., etc. So one of the ways of dealing with that is, instead of me taking the risk that I send you $100 and it actually only $90 arrives, is break it up into really small packets, start sending them, and figure out what the exchange rate is. In the very first response you send me tells me the route that I'm taking to send that packet has a rate. And as I send, I am continuously evaluating that rate. I can configure things like an allowed slippage and so on. So it changes the whole risk model around currency and exchange.
It's kind of similar to buy orders or something.
Yeah, so not a bad comparison. I didn't You could. So somebody who ran a node could use ACH to send on something else. That's completely up to individual nodes to do.
Does this work now?
We've been using it at Coil for 7 months, 8 months. I think we've sent in the order of 10 billion packets to content creators. So,
All right, I think we're out of time for questions. Thank you.
Hello. Okay. Hi, I'm Margaret Warren, and I have a system for describing images using linked data. And what I'm going to talk about in this lightning talk is just briefly some of the concepts behind what that means and what it means to make images as first-class citizens on a linked data graph. And we've lost it. Oh,
there we go.
And I don't have any really great prepared slides, so even though I'm an image person, I'm just going to let you know. I'm actually going to borrow other people's and show a few things of that. But I will be at 3 doing demos that will explain this all a lot more clearly, from 3 to 5 at least in the mesh hall, and then you can find me anytime. So what I want to talk about is that, images. Lots of people put lots of images, millions of images in lots of buckets all over the web. And the truth is, I saw a headline about this the other day that says that 99% of us don't care about 99% of our images, not even ourselves. We're just so used to just throwing them away. They're ephemeral. We don't care. The thing is that there's 1% that we really do care about. And also, they're used in ways that, and images are particularly at fault of being used in ways that they can originate in underground circles, they can escalate up to mainstream media, become clickbait, and they become the kind of clickbait that's used on articles that doesn't have anything to do with that article and causes dissension and misinformation. So this is not from my talk, this is from a talk by Claire Wardell, which was brilliant at the web conference. And this is a great example, because this was a photo of a woman walking past someone who was killed in London, and it uses the thing about Muslim woman pays no mind to the terror attack, casually walks by a dying man while checking phone. Well, that's actually not what happened. Once somebody interviewed someone and found out the Muslim woman was actually very distraught. She was walking by, she was looking at her phone, but because she did not want to look at the person who's dead out of respect. And someone took this image. So is that, it's not a fake thing, it's a real thing that happened, but it was used by a Russian, it was originated by a Russian organization that wanted to disseminate disinformation and, just get people, all stirred up. Okay, so the impact of images is clear, even single images. So how can we think about this differently? Well, I created this application a long time ago to be able to disambiguate the way that we talk about images. So the way that we the way that we disambiguate, say, the way that keywords relate to the image. So we're used to giving, we're used to giving a list of keywords that go with an image or a list of hashtags that go with an image. And those hashtags are very inefficient at actually understanding the content of the context and the intention of where that image came from. So, so here's an idea, here's a concept, and let me find the right screen, and I'm sorry that this is a little bit hectic. So, we already know that AI machines will only get so far with the classification, and that says nothing about the intent. So we've got knowledge graphs now. People use knowledge graphs. They talk about people refer to the knowledge graph, and that is what Google is using. They are using to build their info boxes. Whenever you look up something and over on the right-hand side of the page, you'll see an info box. That's the kind of structured data that Google is putting together and constructing together and building into a knowledge graph to present information to the searcher. But just a more broad definition of a knowledge graph is just nodes and edges. So, and expressed in linked data, this would be in triples, RDF triples, that are made up of linked data. So you would have a URI for a string of triples that would be a subject, a predicate, and an object. And I can show you this a lot more clearly by just using this to do it. So if I'm expressing something that I want to say about, for example, an image, I can say this image shows Margaret Warren, this image shows Riley Taylor. Okay, this is a triple, and this is a subject, a property, and an object value. And when you view the source of this, you can see that. Okay, sorry for the buttons. Okay. Sorry. Okay. Okay, so we're now looking at the source of this. This is RDFA, and this is showing that I'm referring to this image as this image is the URI of this image. This is the property value of what I'm describing here, and then the subject value. When you go down here and find it. Oh, sorry. Let me see. Is it? No. Yay! Okay. All right. Great. Yay. Okay. So the idea is that instead of a knowledge graph just being bits of information, we can have the first class citizen of the knowledge graph be the image itself. So would be a node, and then if we can do anything with this URI. If we can make it an immutable URI, if we can put it on IPFS, we can actually, in a web of trust, we could be able to track the provenance of this image, where it came from, where the source originated. We can track all kinds of metadata, because using something like this, you can separate the data. You can decouple the data from the application, and I know you probably hear that a lot, and you probably already know what I'm talking about. So you take the data and you separate it from the resource itself, and then you're able to keep tracking changes. You can track where it came from, track the content, track the intention, and also be able to, I think it would be a lot easier to stop things like the proliferation of those types of images that are coming from like sources who are originating them and trying to get them into mainstream journalism as clickbait, misinformation. And I think, sorry, this is like so fast to say a lot of information. Okay.
You want to take some questions?
Sure, I'll take some questions.
Actually, one quick check in the room. There's a few people who didn't show up, and I just want to do one last check. Is Duncan here? Michael Brezel? Eugenie Ponorev? No. Okay, so we'll fill the rest of the time with questions.
Okay. Great. Okay, yes.
So is the proposal for the image metadata itself to carry the knowledge graph about itself?
Yes.
Or is this like a discrete?
Yes, it does. So for in the case of like this system, and sorry, I have to keep referring back to my system. My system, you know, it has this. It's like a chameleon. It would look like it might be centralized, but it's actually not, because I can add any URL from anywhere. So any URL can be the source of the image that I add. Then when I add that, what I'm doing after I do this is I'm storing all of this not just in the file itself as RDFA, but I'm also storing it as JSON LD, and I'm also putting this in an RDF triple store. So the triple store is separate from here. Now I can share this, and this is using a tool that I did not create. It's OpenLink software by someone else who works in linked data. And you can see these are now all of the triples that are in this data. And I can click on any one of these. So I created an entity, for example, for Riley Taylor. This is an entity where I describe Riley Taylor, programmer at dWeb. I can share this now on Twitter. In fact, I did share it earlier today on Twitter. When you share it on Twitter, you'll have a nice little thumbnail on Twitter, but then when it comes right back to this page, you can flip it, you can see the triples, you can see the description, and also it carries, and really importantly, I think, the copyright intentions, the copyright intention status that the user wants to convey. So it is stored in a triple store, which can be queried by anyone. So I have this is another example of one where I have a image snippets gallery for WordPress. So anyone can do this, and anyone that has a semantically aware process can use the data that is created and managed in image snippets to build websites with, to do slideshows with. I think it would be perfect on using a solid pod, because you can have a login. I mean, even with Kingsley's tool, and I don't think this is going to work right this second, but if I, with the Open Data Link Data Sniffer, sorry, this is not, I'm going to go there. Let's go back here. Here's an upload button where I can upload raw data. I can go in Turtle. I can log in to my solid community space, which I have here. Then I can upload the data, and I don't know that this is going to work right this second, so I don't know if I should try it, but you know, I can upload this to, I think there's something that I haven't gotten the most recent updates of Solid, but it would work, and you could, and so this data could then be saved. So I think that using something like a Solid Pod login to something like image snippets would allow you to say whether you wanted to make your images public, then put your copyright intentions on those images, and then